this video, what we're going to be discussing is what we consider the 5-number summary and box plots. In previous videos, we've already discussed the usage of measures of position such as percentiles, quartiles, and the like. The box plot and the 5-number summary are ways to represent quartiles, where we've broken it up into 5 groups, and we're going to graphically represent this data. And it's specifically the box plot that we're looking at. We use the 5-number summary to represent that, though. You may also hear the box plot be referred to as what we consider the box and whiskers, and that will make more sense once we draw it out for you. The 5-number summary, the reason why it's considered that is because we use the 3 numbers from our quartiles, the Q1, Q2, and Q3, along with the lowest number and the highest number. That way we have those 5 numbers that represent the data set. What we do is we're going to put on our graph Q2, Q3, and Q1 as vertical lines, not horizontal, as vertical lines. Oh yes, we are drawing horizontal lines from that. Sorry. But we're vertical lines at Q1, Q2, and Q3. And we're going to connect those into a box. And then we're going to put the lowest value and the highest value on there. And draw horizontal lines connecting them to the box. And this is our box plot. The reason why it's also called a box and whiskers is here's your box and we have 2 whiskers, 1 on each end going out, representing that extra data. Remember that between Q1 and Q3 is 50% of your data. So this is the middle major portion of your data and it's the largest group. So that's what we concentrate on. We can use the box plot to look at our data and see, could there be outliers? Is it skewed some? Does it look a little bit off? The big thing here is make sure that when you draw this, you draw it to scale and you don't just do what I did right here, put the Q1, Q2, Q3. Actually make sure that you draw it like on a number line and that the number line is evenly spaced as usual, because it's very important to get that graphical representation. Let's look at what that would look like. So in this example, we have the number of meteorites found in 10 states of the U.S., and those include 87, 47, 164, 296, 30, 215, 138, 78, 48, and 39. And what we're going to do is we're going to construct a box plot. Well, the first thing that we're going to do anytime we look at this is we're going to put our data in order from least to greatest, just like we do where we are looking for the quartiles, percentiles, everything. Because what we're going to actually do is we're going to find our quartiles. And so I have to first have it in order from least to greatest. So let's go ahead and put the data in order from least to greatest. We have 30, 39, 47, 48, 78, 89, 138, 164, 215, and 296. So we now have our 10 numbers put in order from least to greatest. Since there are 10 numbers, my median, my Q2, is going to be here between numbers 5 and 6. So Q2 is going to be here. So Q2 is going to be 78 plus 89, and divide that by 2. So Q2 is actually going to be 83.5. So I now have my Q2. It's halfway between my middle two numbers. Q1 is going to be the median of my lower group. Remember, I do take a 78 in that lower group because that is not Q2. I used it to find Q2, but it's not actually Q2. So I use 78 to find my Q1. So the median of this lower half of the group is going to be Q1, which is 47. And the median of my upper group is Q3, which is going to be 164. So I have 3 of my 5 numbers that I'm going to use. The other 2 numbers that I want to use in my box plot are my lowest number and my highest number. So I now have the 5 numbers that I'm going to use in my box plot. I'll be using the number 30, 47, 83.5, 164, and 296. Now what I would like to do is I'm going to come down here. I already have a horizontal line drawn just like a number line. And since we have a large range of numbers, we go all the way from 30 to 296, what I'm going to do is I'm going to use a scale that goes from 0 all the way up to 300. So we're going to go from 0 to 300. And so let's see. Here will be about 100, and here's about 200. So here's going to be about 50. Here will be about 150. And this will be about 250. So we've got about 25, 75, 125, 175, 225, and 275. This helps me know how to break it up when I'm looking at it. Okay? So using this number line, I want to put these 5 numbers on here. I'm going to start with my Q's and put those on there. So let's look at Q2, which is 83.5. That's going to be somewhere over here between 75 and 100. So here is Q2. Q3 is at 164, so that's down here between 150 and 175. So here's Q3. Q1 is at 47. It's over here close to 50. Well, made that a little bit long. That's okay. There we go. So here's Q1. And I'm going to draw that into a box. So here is the middle 50% of my data between Q1 and Q3. Then I want to put my lowest value and my highest value. So I've got 30, which is about right here, and I'm going to connect it to my box. Then I've got 296, which is up here almost to 300, and I'm going to connect it to my box. So I now have, and I'm going to go ahead and put the values of that, 30 to 96. Looking at this box plot now, I can see that This line is much shorter than this line. Therefore, my data, most of it falls down on this left-hand side, which might indicate that this 296 could be an outlier, like we've talked about previously for quartiles. We can find outliers. That is something that we might want to look at. We can also see that this is a skewed data because the majority of it is down here, and we have a little bit of a tail here. Just like drawing the curves with our histograms, things like that, and we looked at the shapes of them previously, we can do that with this. This is how we look at it. This is going to be a right skewed because we have a smaller tail down here on the right-hand side. Therefore, this is a right skewed data set. Most of our data is here on the left-hand side. So, looking at the box plot, we can see a lot of things from the data, which is what we want to be able to do. Looking at just the numbers, okay, they look like numbers, and I can tell a few things from them, like we have a large range, things of that nature, but looking at a graphical representation, I can tell a lot more from them. My suggestion is that you practice, and then let me know if you have questions.